Hi, my students are trying to do the combined gas law at home and they needed some help, so I am going to go over it now. The combined gas law is pressure, volume, and temperature. So it's pressure 1 times volume 1 over temperature 1. So P1 times V1 over T1 equals P2 times V2 over T2. Not a bad equation. You've got to be pretty good at cross multiplying. We'll go over that in a minute. All temperatures have to be in Kelvin. So if you have a Celsius temperature, what do you have to add, Stephanie?
273.
You have to add 273 to get a temperature in Kelvin, so that there aren't any zero or negative temperatures in the equation. Okay, the worksheet that my students had to do looked a little bit confusing to them. It had everything set up in a chart here. So here's problem number 1 off of my student's worksheet, and I think this is out of Instructional Fair Reproducibles. We've got pressure 1, 1.5 atm, volume 1, 3.0. The temperature 1 is 20 degrees Celsius, which is 293 in Kelvin. Pressure 2 is 2.5 atm. V2, volume 2 is missing because that's our unknown. You're always going to have one unknown every time. And then T2 is 30 degrees or 303 Kelvin. So I took this and I set this up in the equation. It's pressure 1 times volume 1 over temperature 1 equals pressure 2 times our unknown V2 over T2. I don't know if everybody watching this knows how to cross multiply, but when you cross multiply, the product of these 3 numbers equals the product of the other 3 numbers. You can cross multiply and it's going to take you a few minutes to solve it, or I have a very good shortcut. If you multiply those 3 numbers, we have 1.5 times 3.0 times 303. If you get that product and then you just divide by both of those other numbers with your unknown, you're going to get your answer. Because you have to divide by whatever's with that unknown variable. So we can just, instead of dividing by the product, we can just straight through divide by 293 and divide by 2.5. So 1.5 times 3.0 times 303 divided by 293 divided by 2.5. You should get an answer of 1.86 liters. So give that a try and make sure you get that answer, okay? Now we're going to try problem number 3, just so that you have a couple examples. So, let's see. Okay. So here's problem 3. We have P1, V1, T1, P1 and V1, and now this time the temperature's missing. That's on the in the denominator this time. So let's set that up. Okay, so now this time, so you have the 600 times 2.5 over 295 equals 760 times 1.8 over T2. So this time we have these 3 numbers cross multiplying, so it's the X, right? We've got the product of these 3 numbers equals the product of these 3 numbers. So we're going to multiply 295 times 760 times 1.8, and now we're going to divide by 600 and divide by 2.5, okay, to get our answer. So it's just a shortcut. You can cross multiply or you can rearrange the equation, whatever you'd like to do to solve this. I wish I could call in my students right now. Jermaine! But when you do this, 295 times 760 times 1.8 divided by 600 divided by 2.5, it comes out to be 269 Kelvin. And now how do you get from Kelvin back to Celsius? What do you subtract?
273.
Okay, so we have Kelvin over here, so the answer is going to come out in Kelvin. If we want Celsius, all we have to do is subtract that 273, and then you are going to get -4 degrees Celsius, so the answer can either be 269 K or -4 degrees Celsius. Okay, thank you.